Hello, class. It has been so long. I miss seeing you at school every day. But we are going to start our new unit. This is actually an honors topic unit. It's going to be going more in depth of some of our trig functions and equations. So this one can be a little bit tricky sometimes, but I believe in you guys. And if you watch these video lessons, you should be just fine. It's going to be just like we're at school. So we're going to be looking today at how to solve trig equations. So solving trig equations, you're going to need to know your unit circle. So hopefully you remember that. If not, refresh it. Or you can have one to look at. I just drew this one up, so pretty. And you'll need to remember a lot of the trig identities that we've learned. So like SOHCAHTOA and stuff like that. So you'll also just need to think in order to solve these. It's not going to be as straightforward as some problems that we've done in the past. So it might take a little bit more work than you're normally used to. You can't just go with the flow a little bit. So what we're going to be doing is today solving trig equations. It's going to be really similar how you would solve regular equations, like a quadratic equation. So just how we would try to solve for x, we would try to isolate x. We're going to be doing the same thing. So first you want to isolate your trig term. So if you have a sine function, get that alone, cosine, whatever it is. We're also going to be using our order of operations to do that. So make sure we're doing the right steps in the right order. And then sometimes you might have to factor. So just kind of keep that in mind. And then when we're solving these, they will ask you to either do radians or degrees. That will change on each problem. So you'll just need to look at the directions and see, do they want their answers to be in radians, which are with the pi's, or degrees are numbers. So let's look at one. Let me zoom in on this one. So this first example, we're trying to solve for x, which is inside the sine function. So first thing you want to do is you want to try and isolate sine and get it by itself. So we're going to do that by subtracting this 2 over to the other side so that we get those to cancel, and we have sine x is equal to 1. And so then once we are here, you can actually just go straight to your unit circle, or if you have it memorized, that skips a step. But we're wondering, when does sine equal 1? And that's going to give you your x value. And let's just do radians for our answer on this one. So I would just look at my unit circle. Remember, sine is going to be the y value, cosine is the x value. I also have the tangents written in purple around my unit circle. You might want to do that to yours as well. So here's cosine, sine, and tangent. So we're looking, when does sine equal 1? And that's here at 90 degrees or pi halves. So then again, depending on if you're giving your answer in radians or degrees, you would take one of these. So we want radians, so we're going to do pi halves. So sine equals 1 when x is equal to pi over 2. So that would be your answer. So that's an example of an easy one. They do get harder than that. So let's keep going. You'll see some harder ones. On this next one, we have a tangent squared. So again, the weird thing about when we square our trig functions, they put the little square in between the x and the trig function. So this is saying tangent is squared, not x. So your tangent squared of x plus 3 is equal to 0. So again, we want to start isolating to get that alone. So we're going to minus the 3 over, and we get tangent squared of x is equal to negative 3. And then again, we want to try and get this alone, so we need to get rid of that square. So we're going to square root both sides, just like you normally would. So that cancels, and we get tangent x equals square root of negative 3. So here we do have a square root of a negative, which is not allowed, right? So on this one, it would be no solution. That will happen sometimes, especially with tangents, because tangent is undefined in a couple places in the unit circle. On this one, it could be tricky to get messed up on this answer, because if you look at your trig values, which again I wrote in purple around the unit circle, we have a lot of square roots of 3s and negative square root of 3s, but the tricky part on this one was that negative was on the inside of that square root, which we're not allowed to do. So just kind of keep that in mind. Don't get stuck on that one because we're used to seeing a square root of 3 with tangents. Okay, here's another one. So on this one, you'll notice we have 2 cosines in here. That's a pretty good sign that you'll probably have to factor. Just like if this was a quadratic equation, if this was like 2x squared minus the square root of 3x, you guys would solve it by factoring. So we're going to do the same thing on this one, but instead of just taking out an x, the common term in each of these is cosine. So I'm going to factor a cosine of x out of each of these terms. So if I take one cosine away from here, I'm still left with a cosine. If I take a cosine away from this term, we just have the square root of 3. So it's factoring just the same way as if this had been with x's. Maybe I'll even write that out. If I have 2x squared minus the square root of 3x, on this one, you guys would still just factor out an x, right? And we would get 2x minus the square root of 3. Only difference is we're doing cosines instead of x's over here. So we're going to solve it the same way. So just like you would solve this, once we have it factored, you're going to take each part and set it equal to 0. So I have cosine of x equals 0. And then I have this equation, 2 cosine x minus the square root of 3 equals 0. So this one's easy. It's already solved. We just want to know when does cosine equal 0. So if I look at my unit circle, again, cosine's the first term, this is sine, and then in purple I have tangent. So if I'm looking cosine's 1, cosine hits 0 here at pi halves, or 90 degrees, depending on what they ask for. And it also hits it at 3 pi halves, or 270 degrees. So we have 2 answers for this one. We're going to do the radians. So pi halves and 3 pi halves is one part. So we have 2 answers for this part right here. And then on this one, we're going to have to do some solving because we need to still get cosine by itself, so we're isolating it. So again, here's your order of operations. We need to get rid of the negative square root of 3 first before we get rid of the 2. So we're going to add square root of 3 over. So those cancel, and we get 2 cosine of x is equal to the square root of 3. And then now we're going to get rid of the 2 by dividing by 2. So those cancel. So we're looking, when does cosine equal the square root of 3 over 2? And it's positive, right? Not negative, because we're going to have both of those on the unit circle. So when does it equal a positive square root of 3 over 2? So we look at our unit circle, equals positive square root of 3 over 2 here at pi over 6. And then it's also going to be positive in the 4th quadrant. So at 11 pi over 6. It's negative in the 2nd and in the 3rd quadrant. So we have 2 answers for this part. So we get x will also equal pi over 6 and 11 pi over 6. So this answer, or this problem, actually has 4 solutions to it. So when we use this, any of these 4 options for our x value, our equation works. So and we have 4 answers, and that happens sometimes. I've even seen some that get up to like 6 solutions. So it's okay to have a lot of answers on there. Oop, knocking my tripod over.